Hello. So as for the fourth problem, so we have here a supply chain problem with a calendar business pertaining to their expected profits given uncertainty. So with uncertainty involved, it utilizes tools in operations management, uh, such as the expected value, such as the economic order quantity, and overstock. So with with the given right here, you can see that and the given is mostly about the probabilities. So we have the standard deviation, the expected demand, as well as the costs related to overstocking, service level, etc. So to compute the optimal cycle service level initially, so we just have to divide, no, the costs of overstocking and understocking. And as for the optimal order quantity, we use normal distribution. We assume to have a normal distribution, and given a service level of which is zero point 0.7, no? So it explains what demand or quantity should I expect for my orders. So that's one of the outputs. As for the expected profits, uh, it it is composed of four parts. So firstly, the expected profit from sold units. So likely sold units. So there's all the likely sold units. There's also uncertainty of demand. You never know whether the whether the demand of the business will be stable or not, as well as the cost of the ordered stock, whether it is enough to fulfill the demand and the sold units and expected sold units, and finally the expected profits when the chance given the chance that it is stock out. So using the various normal distribution commands, no, so the first part, basically this part, the first part, it basically finds the z value, which is computed by uh, optimal, or not optimal, just the regular order quantity minus the mean divided by the standard deviation. So in the first part, for the likely sold units, it explains, no, what's the chance that the demand will be less than or equal to the order amount. So that's what the first part of the command here entails. And in the second part, uh, this is a slightly different usage. So instead of finding the probability of the curve, it finds the height of the standard normal curve at the specific z value. So because demand, you cannot really expect that it has a lot of variability. You cannot expect a fixed demand given an uh, unlikely ordering costs, unlikely deviations, etc. So it's used as a corrective term for the variability. So it adjusts the expected profit for how steep the curve, no, as it the demand curve, as it's yeah as I've said, it's not constant, no, as it it really ramps up as it approaches the order quantity. And then for the rest of the for the rest of for the formula, no, this third one, this explains, no, how what's the probability that my actual demand is equal to the order quantity itself. So that's the function of this command. And then lastly, the expected profits when stock out. This is just the inverse of the expected profit from likely sold units. So that explains, just one minus the command used earlier. So all in all, that that results in expected profits of $403,000. So as for the overstock, no, it also uses similar principles, and and we have reached, no, 70,869 units of overstock. And this is the part without discount. But when discount is considered, it slightly changes the the cost of overstocking and understocking, as well as the resulting expected profits and expected overstock. So just like before, just compute the given, the what is asked through the same formulas. So as you can see right here, the expected profits with the discount is slightly higher than the one without discount. So it has around $7,000 to $8,000 difference. So with discount, the business can expect to earn more. However, the overstock naman, it jumps really high, no, from 17,000 to 31,000. So the business can expect, no, while the business can expect marginally higher profits, it also has a lot more overstock in general. So there's more uncertainty floating around. There's more chances that the amount of amount ordered will not be sold all the time. So that is the first part of the problem. So thank you for watching.